Today we are going to learn how to find the area under the curve in a normal distribution. In this particular skill, we will learn how to solve probability question when we are given the mean and the standard deviation of a normally distributed sample or population. Now in this word problem, it says that the average height of the students in Barstow High School from a normally distributed population is 67 inches with standard deviation of 2.5 inches. Now what is the probability that a student is 70 inches taller than the rest of the students in Barstow High School? And we'll have several steps on how to solve this probability question using a normal distribution. And the first step is to write out the given numerical values in the word problem. So we have the mean, which is 67 inches, the standard deviation of 2.5 inches, and x, which is equal to 70 inches. Now that we have all our numerical values, we can use the formula for our Z-score so we can standardize the value of our numerical values given in the word problem into a standard normal distribution. So the second step is to use the Z-score formula, which is x minus mean all over the standard deviation, and by direct substitution, Z-score or the Z value of our distribution is equal to 1.2. Now this 1.2 right here will make sense if we'll be able to illustrate our normal distribution similar to step number 3. So on step number 3, we are illustrating with the use of a graph on how to locate 1.2 in a normal curve. So in a standard normal curve, the middle or the center of your distribution is equal to 0. So your mean is equal to 0 with a standard deviation of 1. And the value of 1.2 is an approximated distance from 0 to 1.2 right here. So this will be your Z-score under the normal curve. And since the question in our word problem is to find the probability of a student being 70 inches taller than the rest of the students, so that means that the inequality that we are using will be the greater than symbol. And the greater than symbol is covering the area under the curve in this particular density curve. So in our notation, since we have our Z-score of 1.2, we can write out the probability question in this particular symbol. So we have P, or probability of Z-score greater than 1.2, which is basically telling us what is the area under the curve for Z greater than 1.2. And to be able to find the area under the curve, we're not going to use any mathematical formula, but a calculator function in our TI-84 that will generate the area under the curve, which is the probability in this particular question. So let's have our calculator ready to have the area under the curve for this particular word problem. So in our step number 3, this is our density curve, and the syntax or the algorithm that we're going to use in finding the area under the curve using TI-84 will be the second function, vars, and then press number 2, so NormalCDF will appear. So NormalCDF is the function that we will use in our calculator to solve for the area under the curve. And the syntax for using NormalCDF, you will need 4 numbers to be able to use the NormalCDF function of your calculator to generate the area under the curve. And that is the minimum value, the maximum value, the mean, and the standard deviation. So looking at your density curve, this is the area under the curve, and the minimum value right here is this line in our normal distribution, and this line right here is represented by 1.2. So we will start at this line or the wall at 1.2 all the way to the positive infinity. Now this positive infinity right here in TI-84 can be represented by 1E99, and I'm going to show you how to generate 1E99 using your TI-84. Then your mean and the standard deviation. And since we are using the Z-score, which is a standardized value, the value of the mean is equal to 0, and the value of the standard deviation is equal to 1. And by just plugging this in your TI-84, you will get a value of 0.1151. Now, this might be a little bit vague because I'm just showing you how the calculator function works in your calculator. So now I'm going to let you see how it looks like in the screen when you're using your TI-84. So this is your TI-84. So we need second function in vars so that we can find a normal CDF in our calculator function, which is on number 2. So push 2 and you will have normal CDF. Now that you have your parentheses, you will need your 4 numbers, which is minimum, maximum, mean, and then the standard deviation. And in our minimum value is 1.2, which is your Z-score, comma, your maximum value is the positive infinity, which is 1, E, which is second function, comma, 99. So this is the representation of the positive infinity in your TI-84, comma, the third number is your mean, which is 0, and the standard deviation of 1. And then close your parentheses, and you will find that the area under the curve is 0.1150697, and so on. And in this particular problem, we will use the area under the curve and round it up to the nearest 10,000. So our value for the probability of Z greater than 1.2, or area under the curve from 1.2 to the positive infinity, is 0.1151. So therefore, to answer our probability question, the probability that a student will be 70 inches taller than the rest of the students of Barstow High School is therefore 11.51%. And that is how we use the calculator, or TI-84, in generating the value of area under the normal curve and answering probability question for our normal distribution.